So, how is everybody doing today? Can you guys hear me? See if I can open up some chats and questions here. Good deal. I think everybody can hear me. We're going to give everybody just another minute or two to get logged on. We got most everybody here. I think we're still waiting for quite a few more people. So let's stand by for just a couple of more minutes, and then we'll get started here. So. Okay, so it looks like we're right about at the top of the hour here, so I want to go ahead and kind of get started. I want to be respectful of everyone's time. I appreciate all of those that have attended and joined in. I greatly appreciate you guys hopping on this little webinar here. We're going to review the newest and latest and greatest commercial controller with Rainbird, the new LX-IVM controller. Kind of go through that here today. So appreciate everybody hopping on today. And going through this LX-IVM webinar series is going to go over this. I am going to do some follow-ups. This is just going to cover a little bit of stuff, the kind of the basics and the introduction of some things and kind of how to start looking at it. I will be doing other videos on how to do some manual operations, how to enter in decoder addresses, and kind of get more into kind of the how-tos. So feel free to follow me on Instagram, Twitter, or LinkedIn. My handle there is @SprinklerPope. And so feel free to follow me on those. I will be releasing videos throughout the rest of this month, short little 1 minute, 2 minute, 3 minute video clips about how to do more stuff with the IVM and get a little bit more into details with that. So on with this. The agenda for today, we're going to review the IVM products, the technology. I want to spend a little bit of time with the IVM design and the layout. And the reason that I want to do this is really just to help you understand and how to best optimize some of the features that we've built into the IVM controller, how that helps set us really apart from the competition and from the others that are out there. I'll touch a little bit on surge protection and grounding. As you all know, I think with 2-wire systems, that is something that is that is key with a lot of that. So I want to touch on that just a little bit. And in addition to that, if you'll look on your GoToWebinar pane on the right-hand side of your screen or wherever you've got it hidden, there is a couple of handouts in your handout section. There's a tech spec and a sell sheet on the IVM controller. Feel free, those are PDF documents. Feel free to grab those and download those and use those as you see fit. So two-wire systems, they're certainly the future. I know that if any of you guys have known me for any length of period of time over the last 7 or 8 years, as I have gone across North America and taught multiple different contractors across the country about two-wire systems, I have said for many, many years that two-wire systems really are the new thing in technology. We hardly ever see hydraulic systems and controls. We've transformed and transformed how we actually control irrigation out in the field. And I've said it years ago, and I'll continue to say it, and I believe that the manufacturers are recognizing it. Two-wire really is the future of irrigation control systems and packages. So knowing that, there's just so many benefits to that, right? It's just better, 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 and more better, right? It's just we reduce costs. We do all sorts of different things, as you can see. So two-wire systems just really are a much better, much superior way to do this. So Rainbird set out to really establish and had some goals in mind regarding the next generation controller. What is this controller? Our goals were simple. It was to create the easiest to use controller, not one that was complicated, but one that had a lot of features built into it. We genuinely, as we always want to do, we want to create the best in class specifications for our products moving forward. And we really wanted to create something that really revolutionized two-wire systems using that innovation and technology. So what is the result of those goals? We started these goals and we established these goals 10 to 12 years ago. This is not something that we started last year or 2 years ago. This is something, and these goals were established 12 years ago. The result, after many, many years of looking and reviewing this and doing the work and dedication, is truly, in fact, the ESP LX-IVM controller and the IVM field devices. So what is an IVM? What is this thing that we're talking about? Well, ultimately, it's an integrated valve module. What this is, as you can see, an integrated valve module just over this valve here, truly is a decoder and a solenoid and all that technology built into one device. This sits on top of the irrigation zone valve, and this device itself has this technology in it. It truly makes an irrigation valve a smart valve. It actually has the ability, the circuit boards and the technology that's built within this integrated valve module, to actually initiate. It has intelligence in it. It initiates communication and conversation back to the controller when it feels like it needs to, as well as it has the ability to receive communication, commands, and direction from the controller. So this truly does create the opportunity that no longer do we have a valve that just listens. We actually have a valve that has intelligence built in it and can respond back to the controller and tell the controller what's going on. It is true two-way communication. By doing and able to combine the decoder and the solenoid into one, we're able to eliminate 50% of our wire connections. As you guys know, with two-wire systems, some of the biggest problems that are out there now is that two-wire systems have their biggest problems are wire connections. If we can eliminate 50% of wire connections, we have eliminated the opportunity for defect in that system. So truly, by being able to combine the decoders and the solenoids into one device, this integrated valve module, by eliminating 50% of the connections that go into your system that you design, that you build, that you install, we have automatically, by choosing the IVM controller, we have automatically increased your ability to be successful with that system long-term by 200%. Your success rate is now doubled compared to any other two-wire system that's out there that you use, just by that one process of being able to do that. So let's go over some IVM. Let's review some of the IVM products. We've got two different controllers we're going to talk about today. We're going to talk about the IVM controller, and then we're going to talk about the IVM Pro. We're going to talk about some of the components that go with it, the IVM SOL, the IVM SEN, the IVM out, and the IVM SD, or surge device. So let's talk about the IVM controller. This is what we now call our better controller. The LX-IVM controller has 60 stations. It can do 5 master valves, 5 flow sensors. We're able to connect up to 4 weather sensors to this one controller. We do one of them local at the controller, and then we have the ability to add 3 additional weather sensors anywhere along the 2-wire path. We can do 8 simul stations, basically meaning we can run up to 8 stations all at the same time. And we can have 10 programs. The 8 simul stations is in addition to the 5 master valves and the 5 flow sensors. So theoretically, yes, we can be running essentially 13 valves plus 5 flow sensors. So a quick overview of the LX-IVM Pro. How does this Pro differ from the IVM? Well, the IVM Pro has 240 stations. It has 10 master valves, 10 flow sensors, 8 weather sensors. Again, one of these weather sensors is local at the controller, but with the Pro, we're able to add 7 weather sensors out to the field, whether that be additional rain sensors or whether that be freeze sensors, whether that be soil moisture sensors that you want to add, whatever that may be, we can do that. We then also can operate 16 simul stations. That's 16 stations all at the same time. Again, in addition to the existing 10 master valves, that's 26 valves operating at the same time, plus an additional 10 flow sensors. With the LX-IVM Pro, we have a total of 40 programs. That's a lot of programs. You can do a lot of different things with 40 programs. A quick look at the back of the faceplate of our IVM controllers. We're able to quickly see that we do have a reset button in the back. We do have a 5-pin accessory connections for remote controls. And remote control technology, or TRC as they're called, they do have an adapter that works with this unit. So there are long-range remotes out there that do work with the IVM. And then we also see the IQ NCC communication cartridge slot. This is where and how we'll be able to take our IVM controller and connect up a communication cartridge so that we can then see central controls. We'll be touching a little bit later on today. I do have another webinar this afternoon about IQ4 and about central controls, and we're going to talk about that in another webinar. So if you want to understand more about central controls, tune into those. What are some of the components that go with our IVM controllers? The first is the IVM SOL. This, again, is the technology. This has all the circuitry and all the technology built into it and truly does allow us to communicate back to the controller. This fits right on the top where the solenoid goes. This works on all of our Rainbird commercial valve lines. It is not compatible with our contractor valve lines or the DV or HV valve series. So we do want to make sure that the IVM SOLs are working with our commercial valves. These are AC solenoid latching solenoids. So this latching mechanism, this AC current, does allow us the opportunity to be able to latch these solenoids, which gives us the opportunity to operate multiple valves at the same time. This IVM SOL comes in a kit, nice package kit. It comes with the adapter that's on the bottom of the IVM. It comes with 2 wire nuts, 2 grease caps. It also comes with a white little solenoid seal. You're going to replace this solenoid seal only when necessary. It's not something that you'll do on every one of them. That replacement solenoid seal is actually in the valve itself, and that's there just to replace if you feel like that's needed. We do have PEB IVM SOLs coming soon. That's basically going to be our PEB valve line, PGA valve line, and brass valve lines that will have the IVM SOL pre-installed. So you'll be able to order these valves with those pre-installed. We are working on building up that in our inventory currently, so they're not available today, but they are coming soon, so stay tuned for those. A quick little drawing shows us the typical installation of an IVM SOL on a valve, Rainbird commercial valve. You can see here, typical installation, 2 wire nuts. Truly the simplest and easiest of all 2-wire systems to install. 2 simple wire nuts connected to the IVM SOL, and you're done. The next component that we want to talk about is our IVM SEN. This IVM SEN is for our sensors. This is for weather and flow sensors. We'll be connecting and using these sensors with the same flow sensors that we've used throughout the past with all of our LXD and LX-MEF controllers. These are the same flow sensors that we've used, our FS series flow sensors. You can also connect up the RSDBEX rain sensors. You can connect wind sensors as well as soil moisture sensors as well out on the 2-wire path. Quick little demonstration shows you basically how that's connected off the 2-wire path. And then a quick installation guide shows you that these are installed similar to how we have installed sensor modules and sensor decoders in the past. 2-wire connection connects to the 2-wire path, and then the output of the IVM SEN does actually connect to the sensor, whether that be a flow sensor or range sensor. Next component we want to talk about is the IVM out. This is an output module that we have specifically made so that it will accompany our IVM pump start relays. There is a specific pump start relay that we will have for the IVMs. As the IVM outs and the IVM is latching technology, we do have a pump start relay that has a latching relay that's inside of it. The IVM out also allows us to be able to do work with non-irrigation applications. This is part of the reason why we actually did come out with 40 programs. We have a lot of counties, municipalities, and school districts that want to be able to control their sports field lightings, their gate locks, their bathroom locks, and other things like that. And you're able to do that with 40 different programs. You can set up different programs for gates, sports lighting, fields lighting. You can do all of that and be able to operate that off of your LX-IVM controller. And by connecting the IVM out allows you to take that 2-wire communication path, the IVM out, connect that up to a pump start relay or some other relay circuit within your electrical system, and we're able to turn on those different various ancillary items, sports field lighting and gate locks. This can also be used if you do have third-party valves. So if you do have a couple of valves that are not Rainbird, they may be another manufacturer's, we do have the opportunity to use the IVM out and work with those other valves as well. So we can work and retrofit to those other applications. In those instances, we would need to use a DC latching solenoid on those third-party valves. So you do want to make sure that you understand when we do connect up an IVM out, the output side that is connected to that solenoid valve of the other manufacturer, we do want to make sure that there is a DC latching solenoid on that third-party valve. Quick illustration shows how that would be set up with non-irrigation or non-Rainbird related valves, and then also how we can use that with our pump start relays. Got a quick diagram showing you how this is set up with a non-Rainbird valve. And again, this does need to be a DC latching solenoid. And then this is a typical installation, and these are some part numbers for our IVM output with the IVM latching pump start relay. So typical installation is going to show us that. We do have a latching ice cube relay inside of here that would be connected and allow us to do that. We do have 2 different pump start relays, one that would be used for 110 volts to start a motor, or we do have one that's rated for 220 to start pump start relays, pump motors as well. Next, we're on to our IVM surge device. This surge device and the spacing for that is going to be still every 500 feet. So that spacing requirement is exactly the same as our LXD. We still want that surge device to be every 500 feet. But we are going to allow you with the IVM to go every 15 field devices. So this allows you to have more IVM SOLs, more IVM sensors, and more other modules in between surge devices. We did want to give you that flexibility, but we still want to have one about every 500 feet. Typical installation again on this, we do want to make sure that we install our surge devices at the end of our 2-wire path runs, connect those up to your grounding rod, grounding plate, However you want to get your grounding done there, connect those up there. Typical installation is going to show us how the IVM is installed with an IVM SOL, the surge device installed with that. And then again, we do have that connected to the earth ground. We do want to make sure that that earth ground sphere of influence, when we do create those grounds, we do want to make sure that that sphere of influence, or where that earth ground is actually located, is about 10 feet or so away from our field devices, our wire path, our valves, that sort of thing. So make sure that you locate all of your earth grounds away from any field device and away from any other potential earth grounds that may be around. Parking lot lights, ball field lighting, etc. Those all have earth grounds as well. We want to make sure that our earth ground is separated from theirs. So let's get in and talk a little bit about our two-wire system design. And again, this is what's also going to help us a little bit with some of the features that's built into the IVM. What do I mean by that? The IVM base module, we've redesigned that. It now has 4 independent outputs down here at the bottom. Though we've had 4 outputs with our LXD controllers in the past, all 4 of those outputs with our LXD controller is all the same electrical circuit. This holds true for all of our competitors, as the output modules for all of these tend to be exactly the same circuit, same electrical component. What happens is when somebody cuts that 2-wire path or a short is detected, unfortunately that over current draw, because there's a short on that 2-wire path, now shuts down the entire controller. I think we've all experienced that in the past, and those are never fun to experience those. So what we redesigned with the IVM was 4 independent outputs. They're labeled output 1, output 2, output 3, and output 4. And they actually have little LED lights that will change between green and red right up here underneath the connection ports for each one of those 4 paths. This allows us to have 4 completely separate circuits. If down here, the first 2-wire path that we have, if there should be a break or a short that happens on this 2-wire path due to construction, something along those lines, this wire path may be an overcurrent draw, would turn red and shut down this path. But because we have a second wire path and a separate circuit coming out of circuit number 2 of the IVM module, all of this irrigation will continue to irrigate. It's not going to be stopped. It will continue to irrigate. Whereas our IVM module and the thermal overload protection that's built into this module will detect the short circuit on the first 2-wire path. It will shut the first 2-wire path down and no irrigation will happen. But the second, the third, and the fourth circuit continues to irrigate. This, along with some of the other features, is one of the features that truly set the IVM apart from all of the other 2-wire competitors that are out there. I was just listening to and reading up on one of the other competitors, and controllers that cost twice as much as these, when they have a short, they stop irrigating the entire facility. So keep in mind, when we have a 4-circuit layout, we do want to make sure that we understand the differences in those circuits. Coming from distribution, I'm well aware that we don't want to carry more SKUs in distribution. However, it's highly advisable that when you do create these different circuits, use different colored wire for each circuit. That way, when you create a loop out in the field, you can create that loop and come back in with the same colored wires. We do not want to create a loop pattern and have both wires come in and go to separate terminals. If you have both wires on a loop come back to the IVM controller, make sure that both wires connect to the same circuit terminal in there. These terminals, though they are use a small flathead screwdriver, they can hold 2 14-gauge conductors in each terminal slot. So you do have the ability to install 2 14-gauge wire paths into each wire circuit. So what are some of the LX series features and what really sets our LX controllers apart from some of the others? Some of these features you guys may well know about. but I wanted to make sure that we really understood what they are. Flow Manager. What is Flow Manager? Well, Flow Manager helps us really become an energy manager for us and for what we're doing with our irrigation system. Flow Manager is not going to tell us when there's a leak. That's not what Flow Manager is. Flow Manager helps us be a better water manager. Flow Watch actually tells us what's happening and if there is a leak. These are two completely separate and independent features within our LX series controllers. Keep in mind, these features that we're looking at here on the screen are not just features within the IVM controller, but they're also features with our LXD as well as our LX-ME controllers. We also have Learn Flow, where the controller can actually learn the flow of each individual zone that's out there. We can assign master valves or flow zones to independent zones. We have assignable weather stations. We can implement cycle and soak and have station delays per station. We can create water windows to help us better manage when we want irrigation to happen on our site and make sure that no irrigation happens when we don't want it to. We can do seasonal adjust, not only by program, but we can also do seasonal adjust by months, and we can do both of them at the same time. So what is Flow Manager? How does this work? Flow Manager really does allow us to create harmony between irrigation controllers and our VFD pump stations. It allows us to help better manage our water window that we do have on large sites where we have 240 and 200 zones and stations. That's a lot of stations to be running. We would like somebody to help us manage that so that we can get it irrigated and get all that irrigated within an efficient time water window of 8 or 9 or 10 hours that you have. Flow Manager helps us do that. Flow Manager also really does help us be sustainable. It helps us create that energy efficiency and helps us save quite a bit when you start to look at what it costs to run a pump station. So let's look at Flow Manager. What does it really do? This is a typical irrigation schedule that would be running one station at a time. Flow Manager is off. And so though the flow of this system and the capacity is 120 gallons a minute, whether it be a water meter or whether it be a pump station, our average flow rate is only 40 gallons a minute, though we can do 120. So what happens is while we're running this, we have a lot of opportunity to be irrigating, and we don't. So that extends our irrigation all the way out, and this program has us running for nearly 14 hours. When we implement Flow Manager and turn Flow Manager on, nothing else changed with the scheduling, nothing else changed with the run times of the individual stations. But when we implement Flow Manager and turn it on, we're able to run multiple stations at the same time. We essentially set up a rule with Flow Manager that says, look, our water source is 120 gallons a minute. We would like for you to run 120 gallons a minute or as close as you can to that, but never exceed that limitation. So it runs as many stations as it can. It starts them off and it starts operating. As you can see, a pump station would much rather operate, and a VFD would much rather operate within the efficiency of where that pump is supposed to run, as opposed to having a pump station turn on and off, on and off, on and off, finally turn on for only a few minutes, get back down here, it's turning on and off, on and off. You're cycling that pump and you're just tearing those drives up. You're not doing yourself any favors with the pump motors or the life expectancy of that, and your energy consumption is much, much more because you're running so much longer. We put this all together. This allows our pump to be consistent, run right within its pump curve, maintains that efficiency all the way till the end. We're able to get this same watering done in just over 5 hours as opposed to 14 hours. And this is all done with Flow Manager. We don't have to manage this, and we don't have to do this like we used to do 20, 30 years ago as a manager now. Flow Manager does it for us. There's no flow sensor that's really required. You don't need a flow sensor to do this. We can implement the flow rates per stations, set up the rules with Flow Manager, let the controller do the rest. It's just that easy. When we do have an opportunity to add a flow sensor, now we can actually do Flow Watch. We can know what's going on. We can see the actual flow, and we can see that variation and how that relates back to what was expected. What was expected is in the dark gray. What actually happened is our blue line. You can see where the main line filled up, and then you can see where it ran expected, right around where it expected to flow. Flow Watch allows us the opportunity to really see what's going on and to respond in those ways. So Flow Manager helps us be a better manager. We can set that to on or off, and we can set up those parameters within Flow Manager and those rules that we want everything to operate on. Flow Watch allows us the opportunity where we can set high flow limits, low flow threshold limits, and we can also set flow actions. So when we do see a high flow or when we see a low flow action, what does the controller do at that point? We have built in with this controller 3 different options within Flow Watch of what we want the controller to do. So when we see a high flow threshold, we have the option to alarm only, which is simply just going to give us an alarm. If we're connected to our IQ Central Controls, that controller would notify us either via text message or email and let us know that there's an issue. But the controller would continue on with the program and continue irrigating. We have the option to choose shutdown and alarm. If we choose shutdown and alarm rather than alarm only, the controller is going to actually do that. It's going to shut down. As soon as it sees that fault, that high flow or low flow, it's going to shut that controller down. It's going to stop irrigating, and it's going to send us alarm. The third option that we can choose, if we don't want alarm only and we don't want shutdown and alarm, the third option, which is the one that most everybody uses, is what we call our diagnose and eliminate option. This option truly allows the controller to diagnose the flow issue on its own and eliminate the problem all on its own without any human intervention at all. What does diagnose and eliminate ultimately mean? If we go back and look at our example here where we have 4 stations flowing, if by chance we get a high flow during the situation where we're flowing 4 stations at the same time, the diagnose and elimination process will truly take us through the process. The controller will shut down the main line and shut down those 4 zones that are running at the same time. Then it starts up just the main line, just the pump, just the master valve, and it runs and pressures up just the main line. No zones are running. It looks at the flow sensor. Is there a high flow? Is there flow at all? If it is, that means that there's a mainline leak, and so it shuts down. If there's not, and there's read 0 flow, then it starts and it turns on 1 station of the 4 that it was running. And then it verifies that single station with what it was expected to run. Is it running what it's expected to? If so, it shuts down that station and goes to the second station that it was running and does the same thing. And then it looks at the third, looks at the fourth. Once it finds the station that is flowing outside the parameters that's expected, it then eliminates that flow or that issue. It quarantines that specific zone, pulls it aside, eliminates that area, and then continues on irrigating. It goes back to the other 3 zones that were operating correctly, turns those back on, begins to finish their run times, and then looks to see if it can add another zone and continue on. And then it continues on with that process. Diagnose and eliminate, one of the great features that's built into our LX controller series. So what is a flow zone? We've talked about flow zones, and we set up Flow Manager and Flow Watch for flow zones, but what does this flow zone thing mean? What is that terminology? Well, a flow zone concept for us ultimately is how we look at a main line. And I'm explaining this because I want you to understand the power of this. As we've talked about with the IVM controller, we've got the ability to have 10 master valves or 10 flow sensors. And we can do this by having ultimately, here's an example of having 5 different master valves and 5 different flow sensors. And we can have up to 4 or 5 or 10 different flow zones on one controller. This is an example of a flow zone. It basically means a main line. So a water meter, master valve, flow sensor, mainline valves. We could have a single flow zone, but that has multiple water meters. A loop main line may be feeding from 2 water meters, and then additional flow zones. We could have a large main line that's looped and then have multiple flow sources flowing into that. creating an IVM or LXD with a single flow zone concept. This controller would have one flow zone, but has multiple master valves and multiple flow sensors. In this particular situation with this IVM Pro controller, we could ultimately end up having 10 flow sensors and 10 master valves all feeding into this one large main line. And in doing that, we still have the opportunity to do the flow manager that we've discussed, and we would still be able to do the flow watch, the diagnosing and eliminating, and everything else that we've already discussed. We can have a multiple source. Some folks choose that they want some zones to operate off the lake source. Some of them they want to operate off the water meter. We do have the opportunity to choose between lake source and water meter should we choose to do that. We've done that with a couple of folks just recently with some of the IVM controllers. IVM flow zone, multiple flow zones. We do have the opportunity to establish one flow zone for one area. And again, this particular flow zone would be all by itself. It would have its own flow manager process. It would have its own flow watch process that it would be doing and processing that information for this flow zone. We then have a flow zone number 2. Again, operating at the exact same time within the exact same controller, we now have a second flow zone. This second flow zone, again, is going to have its own parameters established for the flow manager, and it's going to have its own parameters established for its flow watch, which are likely going to be very different than the flow manager and flow watch parameters for flow zone number 1. We then can add a third flow zone, or I'm going to call number 4 flow zone, with the number 4 master valve and number 4 flow sensor, again, with its own flow manager and own flow watch features and parameters to set up. And then again, yet for the 5th master valve, 5th flow sensor, we can have yet a 4th flow zone, or again, flow zone number 5 as I'm calling it. This is a setup that just shows you the flexibility of one controller, one IVM controller, controlling multiple different main lines, multiple different sizes, and multiple different setups. This is a prime example of an IVM controller setup. If you chose the IVM Pro, you would have twice the capabilities that you're looking at on your screen. A true power controller all within itself. So the ESP LX-ME, the LXD, and the IVM series controllers, these are all compatible with our IQ Central controls. And the IQ Central controls, again, just takes it to another realm and allows us to be able to communicate and allows the controller to communicate back to us and let us know what it's doing. IQ Central controls are not necessary in order to do these flow zones. IQ Central control is not necessary in order to do any of the flow watch or flow management features that we've talked about. The adjustments of the flow zones and flow managers, these are built within the controller as a standalone controller on its own. These types of features is what truly separates and allows us to be totally different and better than the rest of the competitors that are out there. With that said, I have sped through this. I want to open up the floor for any discussions, any comments, or any questions. And let me see, I'm going to try to pop out some of your questions. Okay, we have audio, okay, so everybody can hear me, right? Okay. Does the other flow sensors work with our flow sensors? The answer is yes. We do have, and we can work with other flow sensors. So if you have a custom flow sensor, you can set those flow sensors up. If you're not going to use the FS flow sensors from Rainbird, we can work with custom, and we can set up a custom K and offset factor for those flow sensors. So we can do that. Without a flow sensor, Steve was asking about without a flow sensor, the user defines and enters the station demands. Steve, the answer to that question is yes. You do, and you would be able to go in and enter those in. Most of the time, what I really try to get guys to do is to say, look, if you've done a design for this commercial site, just use some of those specifications that come off the design and enter in that flow data as a starting point, and start managing the system at that point, and managing the using Flow Manager from that standpoint. About simul stations, do we have something similar to Hunter's? I'm not sure what Hunter does with their simul stations. I know they do something where they call blocking and grouping, which is really from their golf side of things. We don't really do that. We don't group stations together. We truly look at, when we run simul stations and the controller is choosing what zones to operate and what zones to run, it truly does that from a management of hydraulic standpoint when using Flow Manager. So it looks at and it says, hey, if I've got my first station is 50 gallons a minute, but I can run 200, it's going to grab that 50 gallon a minute station. It's going to grab another 50 gallon a minute station. It realizes it's running 100 and that it has 100 left. It's going to start looking for other things to fill in. It always starts with priority wise. It always is going to start with the highest flow first, and then it's going to start going down from there. So it picks the highest flow zones first, and then starts choosing the smaller flow zones after that to fill in. Okay. Let's see. What type of information might the IVM initiate back to the controller? The IVM is going to basically initiate back to the controller some things where it's actually looking at voltage and how it's operating. So basically what the information that it does give back, it says, hey, look, how is it working and what power is it working and operating at? This allows us to really view and for us to determine if in fact that is operating correctly. One of the key factors, again, and I'll touch on this with a short little video that I'll send out later, but one of the key things that IVM does is it has electrical history. We can go back day by day, the last 30 days. We can go back a full 12 months and go back to what this IVM, this specific station, this specific sensor, this specific output module, what was it doing electrically 12 months ago? What was it doing 11 months ago? What was it doing 10 months ago? What was it doing last week? What was it doing 15 days ago? We can look at what actually each individual IVM module was doing back then. Those are just some of the things that those modules do and how they communicate back to the controller. It tells us what electricity they were operating at and allows us to really pinpoint what's going on and do some troubleshooting there. Hope that answered your question on that a little bit. Let me see what. Yes, the LXD can optimize and do all of these flow manager and flow features as well as that. Can you optimize and use, and I guess, Ruben, you're probably talking about the FD401s and the FD601s when it comes to the LXD and the decoders, how we've had one decoder that operates multiple stations. With the IVM, obviously what we're doing is we're creating smart valves, and that's specific to the valve. So we don't really have an integrated valve module that would be for multiple stations, because the idea is that we're integrating that technology within each valve. So we don't really have that. If that answers your question, that kind of defeat some of the smart purposes of what we're doing with the IVM. Is there going to be an IQ diagnostic tool where you can view current flow data like we briefly had in the old version of IQ? Yes, that is a IQ question, but yes, we can see in IQ4, we can see flow just like we could in IQ3. It's in a different format and a different look, but you are able to see real-time flow in IQ4 as well. So yes. And diagnostics referring to the IVM. We are working on implementing diagnostics at the IQ or central control level. We do not have that in IQ today, but that is on the that is top priority for engineers currently, and they are working on that. Again, that goes back to our IQ platform and what we're doing there. So, but we will be able to do diagnostics soon on IQ4. Keep in mind, IQ is a cloud platform and does all that. The key thing is to understand that the IVM controller is truly extremely powerful in everything that it does. And again, I wanted to kind of show you the idea of a little bit overall view. There is so much more that the IVM can talk about. I think I've got about 15 short little videos that talks about being able to ping the individual valve modules, doing some diagnostics, doing some troubleshooting. There's so much more stuff that goes on, but I didn't want to keep you guys for too terribly long today. I appreciate you guys chiming in, but stay in tune. I am going to be doing more webinars and more stuff throughout the month of April, so stay tuned. Again, plug into some of the social media, and I'll be more than happy to send that out. Next question is coming from Travis. Are there any wire run length restrictions as compared to the old LXD? So great question, Travis. I failed to mention that in this. The wire limitations, Travis, is exactly the same as the LXD. So where we used to run in a star pattern with 14 gauge wire, we could run about 1.62 miles. We're going to be able to do the same thing with the IVM controller. If we use 12 gauge wire, that extends that out to, I think, about 3 miles. And then again, if we did loop it, those limitations are all the same. So the wire paths, the wire specification, the wire path distancing, all of that is exactly the same as the LXD and what we're used to there. So you want to keep using the same wire and the same wire lengths as we have in the past. Okay. Any other questions? We're a little bit early. I'd rather finish early than run over. I want to respect y'all's time. I greatly appreciate you guys joining in. I'll hang out for a little bit more. If you guys have any more questions, please feel free to ask. Again, you can always shoot me an email or do anything else there. I greatly appreciate the attendance today, and appreciate you guys hanging out and spend a little bit of time with me today. All right, I don't see any more questions. Appreciate you guys very much. We went about 45 minutes, so thank you guys. I will look forward to hopefully plugging in with you guys and getting in tune with some of you guys a little bit later. Thanks so much. Y'all have a wonderful rest of your week and work well. Oh, another one came in. Let's see, Hugh. The hydrometers, yes, the hydrometers will work. Again, the same as the LXDs. You just want to be able to there's a certain hydrometer, and I can't think, there's two different kinds, and we want to make sure it's the same one that's worked in the past. If you will shoot me, Hugh, if you'll shoot me a direct message or shoot me an email, I'll get you the specifics on exactly which hydrometer will work with this and how that works out. I will specifically plug into you. So if you'll shoot me an email, first initial, last name, S, Pugh at rainbird.com, I'll directly respond back to that. Or if you want to DM me on any of the social medias, Instagram or Twitter or anything like that, I'll also reply back to you there as well. So whatever works easier for you. I'll get you the specifics on that. I do have that, and I can get you the specifics on that, Hugh. Anthony, is programming the IVM address into the controller performed the same as the LXD? Yes, it is. Yeah, it's performed exactly the same. I do have a quick little video I am going to put out. I'll probably put that out in the next couple of days, probably before the end of the week on social media. So on Instagram, Twitter, Facebook, we do have a little YouTube video channel as well, Rainbird YouTube channel. I'm going to put that little video out on how to program those addresses. It's very simple. It is very much like the LXD controller. So yes.